Transitions, February the 8th through the 12th. We are going to be talking about polynomials. Polynomials are one variable. In one variable are algebraic expressions. So we are actually going to talk about the different types of polynomials. Polynomials are classified by the number of terms they contain and by their degree. Alright, the degree of the polynomial is the highest power of the variable. So for example, 3x squared minus 7x minus 4 has a degree of 2. Alright, it is the highest exponent basically on your in your term. Alright, so it has a degree 2. So this is what we call a polynomial. A polynomial like this only has one term in it. So it's called a monomial. Alright, it is called a monomial. If I have a term like this, it has two terms. That is what we call a binomial. Alright, so monomial has one term. 2x cubed is one term. X cubed, or x to the fifth is one term. Negative 8 is the second term. That is what we call a binomial. This one up here, so I'm going to just use this example again. It has 1, 2, 3 terms in it, so it is called a trinomial. Okay, these are all polynomials, but these I classify them by the number of terms. All right, so what happens if I have something bigger than a trinomial? So for example, what if I have this? It has 1, 2, 3, 4 terms. This is just called a 4-term polynomial. Alright, we don't have a specific name for that. Alright, so what we're going to concentrate on here is adding and subtracting and multiplying polynomials. Alright, so we're going to talk about adding and subtracting first. Polynomials can actually be added, subtracted, multiplied, and factored. A key property for this is the distributive property. Alright, really quickly, let's kind of review the distributive property. So if I have this, the distributive property tells me that I need to multiply the A times everything inside those parentheses. So I would multiply it times the A, B, and I would multiply it times C. So when I do that, I get AB plus AC. Alright? The one thing I notice about distributive property is a lot of times students will multiply it by the B, but they will not think about multiplying it by the C. Distributive property, I have to multiply what's outside by everything inside. Alright, in addition and subtraction of polynomials, this involves combining like terms. Alright, so this is like an application of the distributive property. So for example, let's say I want to add 2x cubed and 3x cubed. Alright, the reason this is like the distributive property is because I could rewrite this like this. Because they both have an x cubed, I can rewrite it just like this, and it looks just like the distributive property. So then I would go ahead and do my inside parentheses, and I get 5, and 5 times x cubed is 5x cubed. Notice that my exponent did not change. All right? So that part does not change. All right. So let's just kind of look at some of these answers here. Or let's look at some problems. All right, we'll just go through some problems. So let's say that I have this problem. All right, so I'm going to tell you the first thing you want to do is go ahead and do your distributive property. So 3 times x squared is 3x squared. 3 times negative x is negative 3x. And 3 times 5 is 15. All right, I'm going to do the same thing over here. And I'm going to treat this as a negative 2. The reason being is it's going to make it a lot simpler on me. So negative 2 times 4x squared is negative 8x squared. Negative 2 times negative 5x is positive 10x. And then negative 2 times negative 3 is positive 6. And now I simply go ahead and combine any of my like terms. So I have 3x squared and negative 8x squared, which gives me negative 5x squared. I have negative 3x and positive 10x, which is a positive 7x. And then 15 plus 6 is 21. And I am finished because I cannot simplify it anymore. All right. All right, so then let's look at an addition problem here. 3x squared times x minus 4 plus 4 times x cubed plus 7x squared minus 5. Once again, go ahead and do your distributive property. 3x squared times x is 3x cubed. 3x squared times negative 4 is negative 12x squared. 4 times x cubed is 4x cubed. 4 times 7x squared is 28x squared. And 4 times negative 5 is negative 20. Combine your like terms. 3x cubed and 4x cubed is 7x cubed. Negative 12x squared and 28x squared would give me a positive 16x squared. And then I have minus 20. And notice that I cross mine out as I go, simply because that helps me keep track of what I've used and what I have not used. Okay? All right. Let's do one more. And this time I'm going to look at this in terms of fractions, because you're going to see this. Notice they all have x squared, okay, which is fine, absolutely fine. I can rewrite this. I can pull that x squared out, and that gives me 1 minus 3/8 plus 5/6. And that shows me what I need to deal with inside of my parentheses. All right, so guys, when we're dealing with fractions, we need to find that common denominator. So I'm going to bring this down. Common denominator with 8 and 6, you can use 24. All right, and I've got 3 terms, so I'm going to have to do 3 terms. How many 24s equal a whole? That would be 24. 8 goes into 24 3 times. 3 times 3 is 9. And then 6 goes into 24 4 times. 4 times 5 is 20. Now I can figure this out. So 24 minus 9 would give us what? 13. 13 I'm sorry, 15. 15 plus 20 is 35. So I have 35 over 24. Now multiply, and I get 35 24ths x squared. And you can leave it just like that. You do not have to simplify it anymore. All right? Really, that's about it when it comes to adding and subtracting polynomials. Let's do a really quick run through of how to multiply polynomials. So you saw how you use the distributive property when you are adding and subtracting. All right? We also use the distributive property to expand. When we did problems like this, we were expanding by multiplying through. All right? So this is what we call the FOIL method. All right? That's part of the distributive property. Hopefully you have learned the FOIL method. If not, we're going to look at it just a little bit. So let's say that I want to multiply 2x minus 3 times 4x plus 5. All right, so we use what we call the FOIL method. We are going to multiply the front 2, which is my f. So I'm going to do 2x times 4x. Then I'm going to multiply my outer 2. That's my O. So then I have to do 2x plus 5. Or I'm sorry, 2x times 5, not plus 5. Then I'm going to multiply my inners, which is my I. All right, so I'm going to multiply negative 3 times 4x. And then I'm going to do my last, which is my L. So negative 3 times 5. All right, so let's go ahead and multiply that. So I have 2x times 4x is 8x squared. Now I multiply my outers. 2x times 5 is 10x. Multiply my inners. Negative 3 times 4x is negative 12x. And then multiply my last. Negative 3 times 5 is negative 15. Combine like terms. So I get 8x squared negative 2x minus 15. And I'm finished. All right? So that is my FOIL method. You're not always necessarily going to use the FOIL method, but the one thing is you do have to remember to make sure you're multiplying by everything. So let's look at something like this. All right, now, so here's what you have to understand about a problem like this. I have to multiply each part times my inside. So I've got to multiply 3 times x to the 4th, x squared times x to the 4th, and y times x to the 4th. All right? So let's multiply this. So 3x squared y times x to the 4th would be 3x to the 6th y. All right? Because 3 times 1 is 3. I can multiply my x's together, and I just have that y. All right? Then I'm going to multiply this times the second. So 3 times negative 2 is negative 6. X squared times x squared is x to the 4th. And y times y squared is y cubed. Okay? Then I'm going to multiply it times the last term. 3 times 5 is 15. X squared times, there's no x, so I'm going to leave x squared. And y times y to the 4th is y to the 5th. Alright, now I'm going to look. There are no like terms because remember, for it to be a like term, this has to have an x to the 6th y. There's no other x to the 6th y, so therefore I cannot combine anything else here. Okay? Alright guys, that's pretty much the lesson. You are going to get work for multiplying, adding, and subtracting polynomials. Have a great rest of the week.